Hello everyone, my name is Mridul Mittal and I'm a third year undergraduate student in the Department of Mechanical Engineering. Along with me are my teammates Vedansh, Krish and Sudeep. For our ME20092 Mechanics Sessional project, we selected the topic Railway Ladder Mechanics Simulation. The problem statement required us to synthesis and simulate a foldable ladder mechanism that could be attached to a train, allowing passengers to safely enter and exit. Motivation behind the problem. Before starting the design, we analyzed the common challenges passengers face while climbing railway steps. Legacy steps are almost vertical, making them difficult for children. Senior citizens face similar difficulty due to the steep height and angle. The design increases the risk of slipping and falling. To solve this, we took inspiration from a conventional staircase, as people already have that motion in their muscle memory, making it intuitive and safe. Additionally, the stair must be foldable so that they do not interfere with the movement of train. The mechanism must extend for boarding and retract efficiently before the train starts moving.
My name is Kreesh Modi, and now I will explain the kinematic design approach. The theory used behind this project is based on the Grashof criteria, which states that the sum of the largest and smallest links should be should be less than or equal to the sum of the other two links. If a mechanism satisfies this criteria, at least one link may act as a crank capable of full rotation, depending on which link is grounded. If the smallest link is grounded, we get a crank mechanism where two links rotate completely. If the smallest link is adjacent to the grounded link, the smallest link acts as a crank while the opposite link becomes a rocker. If the smallest link is opposite the ground, it becomes a rocker mechanism. If a mechanism fails the Grashof criteria, it is guaranteed to be a rocker mechanism, meaning no full rotation is possible. This theoretical framework guided us in selecting a suitable mechanism for the foldable railway staircase. Now I will explain the prototype synthesis and simulation. We started by developing the prototype synthesis and simulation of our mechanism in SolidWorks. Each component was modeled individually and then assembled into the complete linkage. We used rotational and alignment mates to ensure accurate realistic motion. This digital simulation allowed us to study the folding and unfolding action thoroughly and refine the mechanism before physical prototyping. Here are some pictures of our prototype showing the physical model built according to our synthesized dimension. This is the simulation video of our prototype design demonstrating the smooth transition of the ladder between the open and closed position.
Now, my name is Vedansh Patel. I will explain the assembly considerations in our SolidWorks. So, we basically integrated some components. All individual parts were modeled and assembled into a complete system. We did the rotational alignment. Pin joints were assigned using rotational mates. Linkage coordination. Links were connected using alignment mates, so the entire mechanism moves in a synchronized manner. Now, base reference fixing. The main link attached to the train body was fixed to the severe of the reference of all motion. Ladder positions were fixed. Open position. The staircase is fully extended and safe for passengers to use. Closed position. The mechanism retracts compactly without interfering with train and platform clearance.
My name is Sudeep Prajapati. I would start with prototype challenges and optimization. While working on the prototype, we encountered a problem. The stairs were rotating beyond 90 degree, which was safe and not desired. To resolve this, we needed a controlled stopping mechanism. We used a dead center approach, where the linkage naturally locks at specific angle. Using a simulation tool, we finalized the dimensions. As you can see here, the ground linkage is of 22.5 centimeter. The output linkage is 27.5 centimeter. The input linkage is 18 centimeter and the coupler linkage is 20 centimeter. This ensured that the stairs stop close to 90 degrees in open position while still folding back compactly in the closed position. You can see here the simulation of a model. This is the model in open position. This is the model in open position. Moving on to our improvements in the model, we decided about adding a hard mechanical stop plus a proper limit switches that would improve our model. We decided to shift to closed loop control, which would automate our mechanism. Improving the safety and ergonomics was our top priority. Strengthening the structure and longevity of our mechanism can be a potential improvement. Better testing and validation also consist of improvements that we'll look upon. So in the end, I would like to thank you all. Thank for paying attention.